Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim. Hey, everybody, and thanks for plugging into the TTI Distribution Download. This episode 2 of our Nexperia Battery Life Boosting Series, we welcome back Senior Technical Applications Manager at Nexperia, Mr. Tom Wolf.
Hello, good to be back.
And joining me in the booth is TTI Director of Technical Marketing, Pat Denton.
Thanks, Paula. Great to be back.
Thank you again, gentlemen, for tackling this topic. Hey, Pat, would you remind our listeners why this technology is valuable, why we're having this conversation?
Sure. Extending a coin cell battery's working life significantly reduces battery waste in low-power IoT and other portable applications, while making coin cells a viable power source for applications which could previously only operate from AA or AAA type batteries. Tom, let's go into the Nexperia solution. What is a Nexperia battery booster?
Good place to start. We've already talked about how we're going through too many batteries. Coin cell batteries are being used and disposed of too often. So Nexperia put a goal with really 2 points on it. We said, hey, because everybody wants to use these coin cells for something they were not designed for, let's go ahead and build a circuit that makes it look like it's doing what it's supposed to. So number one, we want to boost the available power out of it. So we talked before, if you try to draw a lot of current out of a coin cell, it browns out. The voltage drops on it and you destroy the battery. So we said, hey, let's find a way to boost the power out of it so we can transmit RF energy or Bluetooth energy to a car, remote, or something like that. And then the second one, which is really the whole meat of the matter here, is we wanted to boost the battery life. We said, hey, let's take these coin cells, the way people are using them, and find a way of designing them so that they will last, here was our goal, 10 times longer.
Wow.
And I think we actually did a pretty good job of doing that.
Nice. And what are the main functions in the battery booster itself?
Okay, the name of this device, as you've seen from the title here, is the battery booster. It's the battery life booster. It is what we call an application-specific standard product. Now, what that means is that this is not a general thing that you can use like a microcontroller and do it anything you want. It is a specific device to solve a very specific problem. In this case, we wanted to have a device which could use these coin cell batteries that want to put out low amounts of current and then drive them into a high power pulse type of application. So it's optimized for that. It doesn't do a lot of other things. There's other technologies coming down the line, but this part was really built for that. So it is not a general purpose DC to DC converter. Please don't ask me to use it for other things. It's not intended for that. It is not meant for charging lithium ion batteries. It has nothing to do with that. It's for lithium coin cells, lithium metal coin cells. And it is not a general purpose fuel gauge. So it's got a lot of neat features on board, but they are all really put together for that one function. Take a coin cell and be able to transmit large pulses of current for RF transmissions. That's what it was optimized to do.
Thanks, Tom. And can you explain a little bit what's inside the battery booster and how it works, its features?
Well, we had to pack a lot of stuff inside, but the key feature is something called capacitive discharge. You ever been to a water park of any time, Pat?
Sure.
Okay, now I'm laughing. I can picture that.
So there's all kinds of fountains and water spraying, but every one of the water parks, one of the features it has is this gigantic bucket up in the air, and you stand underneath it, usually freezing at this point, and it slowly fills, and you wait and you wait and you wait, and suddenly, bam, all the water comes down and totally, knocks you over. That's the fun of the whole thing, of course. That is the equivalent of capacitive discharge. Instead of trying to draw all the power out of that coin cell battery at one time, we're going to pull it out at a trickle rate, and we're going to put it into a storage device, an electrolytic or a supercapacitor. So we'll store it up over a long period of time, because remember, that's what the battery likes, low amount of power for a long period of time. We store it up in a capacitor, and then when that capacitor is ready, wham, we dump the whole thing at one time. The RF transmitter has all the energy that it needs to do its transmission. So we've given both sides of the circuit exactly what they wanted. The battery only sees a little bit of charge for a long period of time. It's perfectly happy, thinks it's running a wristwatch or something. The output side of it, the RF transmission section, gets that huge pulse of current that it needs to send out a big radio signal that goes, 100 feet across the parking lot or whatever it is. So that's the main feature inside this device. It's this ability to store up energy and dump it all at one time.
Without injuring the battery.
Exactly. Now, we've added a couple other features as well, too, because that's kind of a known trick. It's been around for a while. We wanted to add some other technologies as well, too. So the second thing we put on board is a low input voltage DC to DC converter. Because remember, as that battery is used, it starts at around 3 volts nominal. As it gets older, it goes down and it's 2.9, 2.8, 2.7, 2.6. It starts discharging over time. So the first thing we do is we boost that voltage back up to the 3 volts or more to charge the capacitor up. So we're actually boosting the voltage. As the battery gets weaker, we boost the voltage up, so we're keeping the same amount of voltage on the output side of it. So that extends the life of the battery as well too. Even if it doesn't have 3 volts in it, we can still pull energy out of it as it discharges over a long period of time. The other things that we put onto it are on top of that as well too. And this is where it really gets high technology. We do something called adaptive power optimization on it. In other words, there's actually a state machine, a microcontroller of sorts, on board the device itself. And what it does is it watches the amount of current that the load pulls out of it, and it adapts itself based on that. So imagine the first time you turn this on and you charge up your capacitors and you transmit all this data out to the RF. Well, you don't know how much it's going to need in particular because the battery booster doesn't know the circuit on the output side. So the first time it probably stores up too much energy and the transmitter doesn't use it all. Well, you just wasted energy. You pulled it out of the battery, you put it into storage, and you didn't need it out of it. So the next time when it recharges that capacitor, it says, I'm not going to put as much power into it because I know that the RF transmitter doesn't need that much power. So every time you use it, it says, I can put a little less in, a little bit less next time. So it's always optimizing itself as the load changes, as the battery changes over time. It's always looking for that optimal battery draw. Keep the battery load at a known rate coming out of it, and putting just enough into the storage, enough into the big water bucket that you only get wet enough when it finally dumps at the very end of it. It's also got on board its own fuel gauge, so it's keeping track of how much energy it's pulled out of the battery. So it knows, hey, the battery's getting low, and it's got an output pin on it, so it could actually transmit off to a microprocessor that says, hey, your battery is at 60% of life. It's going to die by my estimations in this amount of time. You could do a calculation, then send a warning out to have your technician come in and change it. So that's built on board as well, too. So we've added a lot of features on board. All of these features are kind of known, but nobody has been able to integrate them all into such a tiny package at such a good optimal solution. That is what's unique about this. All the best features and all the best tricks are all stored inside this one battery booster.
That's really interesting, Tom. You've mentioned the aluminum electrolytic capacitor or supercapacitor a couple of times. Is that a part of this, or is it a separate component that goes along with the battery booster?
Now, that would be a separate component on it. So the device itself is the silicon part. So inside the device itself, and by the way, there's 4 variations on it. They're functionally doing the same thing. It depends, how do you want to control it? By an SPI bus from your microcontroller or from I2C? So you have picked that option. The other option is, what is your storage device? Do you want to use an electrolytic capacitor, which are a little bit bulkier, or do you want to use some of the new supercap technologies on it? So I need to have something outside of it, which is my storage device, electrolytic or a supercap device. But I only need to have a single inductor next to it as well, too. If you've been keeping track, there's actually 2 converters inside, the boost converter on the input side and a buck converter on the output side. We only need 1 inductor to work it. So what you get is a really small solution. You get our chip, you get the capacitor, you pick the one that you want on the outside of it, and then you need the inductor for actually driving the DC to DC converters on board. But that's pretty much it. This device can actually run in standalone mode or as a assistant mode. In other words, it can run without a microprocessor if necessary on it. It doesn't need one. It can actually do everything by itself. Or you can hook it up to the microprocessor and use that for, some fancier features and types of things like that on it. So it gives you a lot of variety. Again, though, it's a very small solution. The chip itself, capacitor, inductor, by the time you get done with it, the whole circuit board is not much bigger than the size of the coin cell, which it sits on top of. You literally can put it right on top of it. It takes about the same square inches of board as the coin cell itself.
And have you guys at Nexperia, have you put together any type of reference design for this or anything like that?
And that's exactly why it's nice to design with this part, is we already have an evaluation board available for it. And on board that evaluation is the device itself. We've put a number of capacitors on board so you can actually use the capacitors we've had. We have a load section on board. In other words, if you don't have your end circuit yet, you can wire it up to say, I want to draw this much current for this amount of time on it. So you can actually use it for evaluating your design. Because we tell you that you can get up to 10 times the lifetime of the battery. Your actual application may vary on it. So it's a good way to take your real world application, test it out. The neatest part of this evaluation board, though, is in the very corner of it, there is a second battery life booster device on a little tiny board, which literally is about the size of the coin cell itself. You can snap that off, and then you put that into your end product. So you evaluate it on the big board with all the bells and whistles and interface and software and everything. And then when you think you got it right, you just snap off the corner of the board, put that into your key fob, your e-meter, your alarm sensor, whatever, and actually try it out and see if it works the way that you expected it.
Pat, does TTI stock this board that Tom's telling us about?
Absolutely, we stock it along with the supercapacitors, aluminum electrolytics, and inductors.
Is the device itself an off-the-shelf device?
Mm-hmm.
It is off-the-shelf device, yes.
And we have that in inventory. I see you nodding your head because you're right here in the studio with me.
That's right.
Good.
Yes, we do.
And there's plenty of information on the Nexperia website as well, too. All the data manuals, the user sheets, everything you need for it, including all the details on this evaluation board we've been talking about. It's called the NBM 7100 or the NBM 5100. Those numbers just tell you is it I2C or SPI and electrolytic versus supercap on board. But they all functionally are doing the same type of thing. So you can check it up, look at the information there, and then go ahead and start working on your design.
Okay, great. Are there any other solutions available for this problem?
As I said before, all the ideas which are on board, DC to DC converters, buck and boost converters on board, capacitive discharge circuits, microcontrollers, fuel cell gauges, all those things exist in discrete forms somewhere else already, but nobody's figured out how to make them this small. That's the advantage, is you can take all this technology of all these tricks which are kind of known in the industry already and put them all together in one place, very size conscious, very cost effective, drop it in there, and then increase the life of your battery.
Keep the batteries out of the landfills.
That's the idea.
I love it. Great insight. Hey, can I ask you guys to stick around as we're chatting here at the end? I was thinking the real life applications, right? Use cases. If we could talk about that a little bit, I think that would be really helpful, brainstorming a bit, or helpful for our engineering listeners especially. Can you do that? Would you mind?
Absolutely.
Great. So thanks to our listeners for plugging in today. If you learned something, I know I certainly did, you are definitely going to want to plug into our next episode where Tom and Pat are going to talk about specific use cases for the Nexperia battery booster, technology that can improve your coin cell battery applications.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.